Okay. Like I said in the email, this is the longest session because we got 5 groups in each of these two, but there's no math or anything, so maybe it'll go quicker than I think. We'll give it a shot. So we'll cover station operation and setup, kind of deals with some of the controls on your radio and what they're for, how you use them. On test equipment, we'll talk about a nano VNA, which William brought his brand new one, which he wants to know how to use. Some things about interference, speech processing, what S meters do, operation near band edges so that you don't splatter above or below the band, mobile installations, and emergency backup power with wind and solar and all that good stuff. Here's a typical entry-level modern radio, an ICOM 7300, what I started with, still have it. Great radio. They're currently selling for about $1,000. I still don't know what all the controls do. And it turns out on a lot of the buttons, it's one of these where a short press does one thing, a 1 second press does something else, and a 2 second press does a third thing. So there's a lot of menu items. So one of the first things to talk about is a notch filter. It allows you, basically, it's a band rejection filter that lets you put an attenuation band in the middle of your receiver pass band if you've got some kind of interference, and you can move it around to attenuate that noise signal. Not necessarily get rid of it, but you can attenuate it. Because you could have a carrier from some other transmitter that's you're seeing in the middle of your passband. There's also IF shift, which on a radio allows you to move your IF passband, which would normally be, well, if it was AM, it would be symmetrical around your carrier. If you're doing single sideband, it's going to be either above or below the carrier frequency, depending on whether you're upper sideband or lower sideband. And in a lot of radios, you have the ability to shift that one direction or another if you have some interference, and you can kind of move away from it. In the 7300, they have what's called passband tuning, and you actually have 2 of those pass bands, and you can shift one relative to another. So you can not only shift where it is, left or right, you can narrow it by separating the 2 passband filters.
Robert, are you showing us pictures of anything?
Well, there's one.
I'm only looking, I'm just telling, my screen is like files from your desktop.
Ooh, really?
Yeah, where you have like the G3, it's like a whole list of files, but it hasn't changed the whole time. That's all I've been looking at the whole time.
Okay, well, I'm glad you mentioned that. Let's see.
When you said, and here is, I was like, wait, I think he might be showing other stuff on the screen.
Uh,
Yeah, it's like your desktop document files that it's sitting on right now.
well, I was going to try to turn off sharing and redo it.
I can hang up and call back.
No, that's fine. I don't think it's on your end. I'm just trying to figure out.
I'm wondering if it froze because I saw you when you went to click on G4 amateur radio practices, but that's where it stayed on that list of files. It never went anywhere. So
Really?
Mm-hmm.
Host and share. So you're not seeing anything but that same screen right now, right?
Yeah, nothing's changed. Same screen. Desktop, general class, documents.
Um, well,
You don't have that. Let me do this. Hold that. The next phone might not.
Oh, there we go. It just switched.
Some websites.
all right,
Okay.
I did a new share.
Ah,
So
we're
so
working
you
good now.
see a waterfall and
Yes. An icon.
okay.
Yep. All right.
Okay. If you look down at the bottom left of the display, which is the front of the radio, you'll see the IF passband, and you see that dark area where the notch filter is. So you're actually blanking out that little section of the passband, and you can move where that notch filter is. In this case, it's a typical single sideband filter, so it's like 3 kilohertz wide. I don't know how to get rid of that guy. Oh, there we go. All right, did I change?
Yes. Doing good. It just switched.
Okay. Here's IF shift. In this case, we're looking at a what they call dual passband tuning. And you can see then the bottom one, you got a red and a blue passband filter. Normally, those would be one on top of the other, and you can shift them left and right. So the orange area is the intersection of the two, and that's the resulting passband. And because you can shift both of them independently, you can shift them both left or both right and move that passband left or right, in addition to making it narrower. As far as the exam concerned, it's just the ability to shift the passband. And older radios don't necessarily have the passband tuning.
Just the notch filters.
Probably mostly. Well, let's ask Byron. Would older radios have a notch filter?
Yes.
Okay. Passband tuning? Maybe not.
Yes.
Really?
My old 1960s Drake TR did.
Okay.
TR4.
Okay. Oh yeah, I gave one of those to somebody a while back. He still hadn't powered it up.
The newer radios do it in the digital domain.
Right. It's real easy. But I was thinking about before a digital one, it's not as easy to do.
Yeah.
Okay. So what's the purpose of the notch filter found in many HF transceivers?
Bravo.
Bravo.
Very good. Bravo. There's also one or more attenuators potentially that you could switch in if you have very strong incoming signals that are overloading your RF amplifier on the front end, or your analog to digital converter if you had an SDR radio that had direct conversion. And all it lets you do is put in varying degrees of attenuation of the incoming signal. So what's the purpose of using a receive attenuator?
Apple.
Prevent overload from strong incoming signals.
And in the old radios, we just had an RF gain and an AF gain.
Yeah. Well, you still have those, but you have all these other things. For instance, you have a noise blanker, which mostly I think for mobile operations, but if you have any kind of pulse noise like car ignition Somebody's got a air compressor running by, motors like that generate pulse noise. It actually goes in and reduces the receiver gain for a little period of time to blank that out.
And we used to just put a capacitor on our alternator in the car.
You still do that. We'll get to that.
Okay.
But the radio gives you a thing to try to mask it.
And usually leaving the noise blanker on from up there behind, that's nothing. That's your receiver sensitivity.
Right. Also, you have a noise reducer. And this, depending on the implementation, on an SDR type radio where it's done digitally, they seem to work fairly well without doing a lot of distortion to the incoming signal until you got it cranked up almost all the way. I think mine, I normally run it around 7 out of 10, something like that. And it definitely makes a difference and cuts out a lot of the noise. But that's because it's of the digital signal processing. So how does a noise blanker work?
Wow.
See,
Reduces the gain when it detects a noise pulse.
see, senor.
Sweet.
What happens as the receiver's noise reduction control level is increased?
Will they happen?
Yep, it may become distorted. Like I said, I hadn't noticed that, but it would depend on your radio and how far up you go. I
Yeah.
suspect if I went up to the max, it might make a difference.
Seems like more like frequency or bass that's working than being charged too high. Like if things sound too narrow, stuff like that.
Or you'd think that you had Donald Duck answer your CQ.
Well, that's typical SSB. Okay. Sometimes they have some built-in CW controls, like a CW generator that you can use with a paddle. And one contact on the paddle will generate a string of dots. The other one will do a string of dashes, depending on how long you hold it. So it's like an automatic dot and dash generation, and it has perfect timing between the dots or the dashes. But when you go from dot to dash, then that timing's up to you. So it makes the code a little easier to decode on the other end. And I guess it's more convenient if you know how to use a paddle. I'm not even ready for a key, so I can't tell you much more than that.
I have a nice paddle over at the squadron building at the airport that's never been used.
And the display down the bottom is one of the menu items on the radio, and you just press the keyer button to enable that feature, assuming you have a key hooked up. Another one is sideband selection. I probably should find an additional chart, but in this one, if you see the LSB touch button up here, this is a touch screen on the radio. If you press that, then is that Amanda?
I didn't say anything.
Oh, I heard something in the background. I thought maybe it was you.
Oh, no.
If you press that button, it brings up a menu of all the different modes. So it'll bring up single sideband, FM, RIDI, data, AM, and then those you can further go and select whichever mode. Like if you're LSB and you press it, it brings up SSB. If you press that again, it'll switch it to upper sideband. And if you're doing a digital mode, when you transmit, you can do upper sideband and data, which is what you're supposed to transmit digital like FT8. Uh, they also say that if you've got an interference issue for CW, you can select the opposite sideband. In other words, if you were trying to receive on upper sideband and you got interference, you could possibly switch to lower sideband, because in CW, you're going to get the signal on both sidebands. So it may be clearer on the opposite one. So what is the function of an electronic keyer?
Baby.
Bravo.
And these are also external boxes. If your radio doesn't have a built-in electronic keyer, like the one I showed, you have external keyers that you hook your key up to and plug it into the radio. It does the same thing. What's the benefit of using the opposite or reverse sideband when receiving CW?
Charlie.
Yeah.
Okay. Might be possible. Split mode. If you have a transceiver that has dual VFOs, then you can set it up in what they call split mode, where you transmit on one VFO, which can be a different frequency than the received VFO.
91. Is that real nice?
And I'm just showing where the button is on the 7300. You also will, if you can see it, the main frequency display in the middle, that's 7073, which is a RIDI. Or is it? No, not RIDI. That's Olivia. Olivia.
Oh, Olivia?
Yeah, 7073. Because there's a contest going on right now.
Olivia.
In very small over here, I doubt that Amanda can see it. But that frequency display is your alternate frequency. So if you're, in this case, you were listening on 7073, when you transmit, it looks like this is set to 7.20. So you're going to have a big offset. And the next to the split button is an A/B button for the two different VFOs. So you can switch back and forth and which one is your primary or secondary. You can also monitor two frequencies simultaneously if you're just listening. And that is what allows you to do split mode. Which of the following is a common use of the dual VFO feature on a transceiver?
Yeah.
You cannot transmit on two frequencies at the same time with any one I know of. There's maybe a special purpose one, but
Unless it's failing.
normally you can only transmit on one of the VFOs, but you can receive on two or transmit on one and listen on one. Automatic level control. This is one that if you do digital modes in particular, you have to kind of watch out for. I don't know that it affects, and Byron can help me on single sideband as much, but definitely will make a difference on digital modes. So what you try to do is set up your radio, your microphone gain or audio gain, so that you're not overdriving the receiver, and you keep the ALC control either off of the scale or at minimum. Because what it's trying to do is reduced because you have too much drive level, is trying to reduce your gain. And when it does that, it tends to clip the signal, so you get distortion. And it makes a really big difference in the digital modes. I think for single sideband, you're supposed to keep the ALC down in like the bottom third or something.
That's common for most radios.
On digital modes, you don't want to see it. It's also used to, when you're running a power amplifier, to control the level going into the power amplifier too, so you're not overdriving that. But the same thing applies. Too much ALC causes distortion of the signal. And here's the ALC meter. If you have the meter display selected for the 7300, and the red bar is just showing that the acceptable range, 50%. And as these bars light up as the ALC level increases, so you definitely do not want it to go above the red line. The one below that is compression, and then SWR meter, and then the last one there is drain current on your power amplifier, shows how much current you're actually using, which would be proportional to your power out. So why should the ALC system be inactive when transmitting AFSK data signals? Well, those are digital modes. Bravo, sounds good. Power amplifiers. I don't have one, so I can't give you a great deal of insight. I'm sure Byron knows all about them.
I avoid them.
Well, yeah, he does QRP, so he doesn't need it.
Like thinking about tipping current and tuning those 50 plus years ago.
Okay. They normally have a load control that you adjust for maximum power output while not exceeding your plate current. So you normally have a indicator showing what the plate current is and one showing your power output. And it's kind of a balance between those two. You want to minimize the plate current, you want to maximize the power output. So you kind of look for a dip on the plate current meter. At least that's the way it's explained.
Or the old tubes would get too hot.
Yeah, your transmit tube would start glowing.
A little bit like operating a loop tuner.
Yes, similar thing. ALC also, as I mentioned, comes into effect with a power amplifier, and you connect the ALC output from your transceiver to the power amplifier, and it tries to control the input level so that you don't overdrive the power amplifier, because you will cause possibly damage to it, but a lot of distortion and spurious radiations, harmonics, things that you're not supposed to do.
Solid state RF.
This is a old tube type power amplifier I found a picture of. This is a VHF one, and it has a plate control and the input, which I think is the drive output to the antenna. So you play with these two knobs, watching these three meters over there. And you also have a mode switch that you set it for the type of mode you're running. Although in this one, it looks like it's just controlling power, but if this was an HF one, a more modern one, you'd have the ability to set it if you were doing CW mode, or you're doing single sideband, or you're doing FM, and it would change the characteristics of the amplifier for that particular mode. Oh, Byron showed up. What is the correct adjustment for the load or coupling control of a vacuum tube RF power amplifier? They worded these a little,
Like Bravo,
you're like, Bravo? Minimum plate current?
maximum grid current, one, see. Oh, see,
See.
highest plate voltage is
Oh.
minimum. There we go.
You think?
Yeah.
Do we care about grid current?
This thing in Delta.
Well, grid current, this is the vacuum tube.
No.
Grid's voltage. No grid
No.
current to speak of. I say the way they worded it is not like the desired power output, okay, which isn't necessarily the maximum it can do. It's what you're trying to set it for, like 100 watts or 200 watts or whatever, and you keep the plate current preferably minimum. They just say without exceeding, because it's one of those juggling things, and you can't have both maximum power or minimum.
That's why I give them way every two amplifier I've done.
What is the effect on plate current of the correct setting of a vacuum tube RF power amplifier's tune control?
Yeah.
You see a dip when it's properly tuned. Why is automatic level control, ALC, used with an RF power amplifier? See, right. Prevent excessive drive. Okay. Transceivers, because it's a transmitter and receiver sharing usually the same antenna, it will have a switch. A lot of times it's a relay, sometimes it could be a solid state switch in there to switch the antenna from the transmitter to the receiver or vice versa. And normally the transceiver will have a built-in delay for that switchover to take place, particularly if it's a mechanical relay switch, because it can take some milliseconds. So
you're not transmitting into an open circuit.
right. And you're not transmitting into your receiver.
Yeah.
Which is bad. So it gives it time to do the switch. So when you key the transmitter, it's not going to transmit for whatever that delay is to give the switch or relay time to actually switch.
Like using some repeaters. Don't speak immediately if I get cut.
Right. What is the purpose of delaying RF output after activating a transmitter's keying line to an external amplifier?
There you go, Charlie.
So it's the same thing whether you're going to an external amplifier or the transmitter in your transceiver. There's still a delay there that has to be accounted for. Antenna tuners. And I still don't know why everybody calls them tuners.
Matching.
It's a matching unit or a coupler to match impedances between the transmitter and the antenna.
Marketing people thought it sounded good.
Yeah, it's been around for a long time, and even in new stuff, they still call them antenna tuners.
Rams match.
But its purpose is to match the antenna to, or your transmitter, which is going to be 50 ohms in almost all cases, to something other than 50 ohms, which is going to be something other than 50 for almost any antenna. Unless it happens to be the dipole with the radials, or with the elements slanted down at 45 degrees where you get 50 ohms.
Ground plane.
That's the only, or a ground plane. Here's a typical manual tuner, and it's essentially a pi network where you have this control would be a variable capacitor that's across the line. It's a shunt. The middle one is a variable inductor, which is in series. And the last one is another variable capacitor, which is in shunt. So you play with all three of these and try to get the minimum SWR. This one's got a built-in meter. This happens to be what they call a cross needle. And there's actually two meters here on the left and the right. One of them is measuring forward power. One of them is measuring reflected power. And where the needles cross, they have these red lines on the dial where they've pre-calculated what the SWR is, depending on that ratio of forward to reflected power.
You should have at least one manual.
What is the purpose of an antenna tuner?
I'll say all the above. Yeah. Ooh, does it really reduce? Well, I guess.
Yeah, don't think too quick.
That converts. That's at the end.
Well, let's see. Because the whole purpose of it is to maximize the power transfer.
Yeah.
And that happens to occur at the minimum SWR.
If you put down the antenna end, you reduce the SWR on that feed line.
Yes. So you have less loss
Yeah.
on the feed line, assuming if your tuner or matcher is at the antenna and it's looking like 50 ohms, and you have no additional loss on the transmission line.
Yeah,
because it looks like a 50 ohm line.
That's why I set up my car originally that way with my last antenna. Loading coil, swivel, and match line at the bottom.
And of course, if you have the antenna tuner at the antenna, it pretty much has to be an automatic, not manual.
Yeah.
Unless you like sitting up on the tower.
Yeah, unless you like climbing a lot.
While it's powered.